Hi, this is Tony Northrup for TrainSignal, and in this video lesson, we're going to learn how to configure security for mobile devices. And most of that's going to be covering BitLocker stuff. This is for the Microsoft 70-687 certification exam, configuring Windows 8. This maps to Objective 5.3, which has 4 sub-objectives. Configure BitLocker and BitLocker to go policies. Configure startup key storage, configure remote wipe, which doesn't really exist, and configure location settings, which is so easy it doesn't seem like they should bother with it. But that just means it'll be an easy lesson for you. Let's get started. First, we're going to learn to set up BitLocker with a TPM by going through a real-world scenario. So you're an IT guy and you work from your laptop all the time, but you pretty much keep your laptop at home or in the office and you're not too much worried about the security of it. But your manager is sending you off to a second world country and you're going to have to fly there and you're a little bit worried about your computer getting stolen. And if it gets stolen, you want to make sure that none of the confidential data on your computer is compromised. You want everything encrypted. You might use some EFS to encrypt particular files now, but if you want everything encrypted, you're going to want to use BitLocker. BitLocker encrypts your entire drive. And unless somebody can get your BitLocker PIN or passcode, then they won't be able to get to your data. So let's connect to your laptop computer and set up BitLocker. Here's the start screen, and I'll pull up the tool by searching for BitLocker and then switching to search the settings. Both these two links take you to the same place, so I'll click the top one. And this opens up the BitLocker Drive Encryption Control Panel tool. And if you've used Windows 7, this is going to look really, really familiar. It hasn't changed a bit. So this is pretty easy. Click Turn on BitLocker, right? There's one thing to click, and that's what you do. And then a wizard pops up and basically walks you through the entire process. So BitLocker, once I turn it on, it's going to encrypt every bit of data on my drive. And if for some reason I lose my certificate or whatever it is I used to start BitLocker, I'll be just like somebody who's trying to attack my computer. I won't be able to access those encrypted files ever. So BitLocker provides you with a recovery key. If you, for some reason, lose your BitLocker security, you can type in this 48-byte recovery key. It's long, you're not going to memorize it, and in fact, it's going to be kind of a pain to type in. Now, in previous versions of Windows, you could save it to a file or you could print it. Windows 8 is now integrated into these Microsoft accounts, and that's what I use to log in. So if you have a Microsoft account, it will save it to the Windows Live website and keep it there safe for you, because that's pretty smart, right? I used to print my recovery keys, but it's not like I can keep track of a piece of paper. I lost that paper right away. And if you save it to a file, what then? You store it on a different computer, and what if the wrong person finds it? Anyway, so my favorite way in a small business or home environment without an Active Directory is to save it to my Microsoft account. Now, in an enterprise environment, what happens is the server administrators, the Active Directory domain administrators, will configure some sort of key hierarchy, and they'll configure themselves with recovery accounts, and they'll be able to use their certificates to restore things. But in an individual home small business environment, you'll have to save the individual recovery keys and keep track of them. Now, this option is new to Windows 8. You won't see this in Windows 7. Choose how much of your drive to encrypt. By default, you can see that it chooses to encrypt used disk space only. This is a really important feature, especially for new computers. Now, if you select encrypt entire drive, which is the only option that earlier versions of Windows have, it will encrypt the entire disk, just like it says. So imagine you're in charge of setting up a new PC that has a 3-terabyte drive, and it's only got 20 gigabytes of files on it right now. It's a brand new computer. You want to set up BitLocker. What do you think BitLocker does in Windows 7? It encrypts 3 terabytes, mostly nothing. It's encrypting just all zeros or whatever data is on the drive. And that can take more than a day. It can take a long, long time. What a pain. So the new option, encrypt used disk space only encrypts the actual files that are on your disk. And it's only the right choice if it's a brand new computer or a computer that has never had confidential files on it. What this does is it encrypts just the parts of the disk that are being actively used by files. but there's other parts of your disk that used to be used by files and they're still readable. So imagine you're working on some confidential file on your laptop and you move it to a server at some point and then you delete it from your laptop. You won't see that file in the folder anymore, but the contents of that file are still stored on your disk. They're just kind of out of sight. When you delete a file, it basically is like removing an entry from the table of contents of a book. The pages are still there, you just can't easily get to them. But if you're an attacker, you can get to them. You can boot up say a Linux boot CD and immediately access files that have been previously deleted. So if you use the encrypt use disk space only option, those file remnants which might contain confidential data will not be encrypted. New computers don't have those, so that's why encrypt use disk space only is the right option for a new computer. And it's the option that I'll use now because I know that I copied some confidential files to my computer, but I haven't moved them around, so it should be okay. Now, this asks if you're ready to encrypt this drive. You can see a checkbox that's cleared by default here, Run BitLocker System Check. And what BitLocker System Check does is just makes sure that you can start BitLocker correctly without any problems. People, when BitLocker first came out, were a little paranoid because after all, BitLocker encrypts every bit of data on your drive, and if something goes wrong, you can't get to any of your files or data. That's a little bit scary. So Microsoft built in this tool to perform a system check first. Basically, it would allow you to test BitLocker and make sure that you could get it running before it did the encryption. Nowadays, BitLocker has been reliable for years. I don't think we need to do system checks anymore. So I'll leave that clear and then just start encrypting. Now we can see that encryption is in progress. And this is going to take a while. So what's going to happen is when this gets to 100%, well, I won't notice anything different. I can continue using my computer and eventually it will finish encrypting. At that point, my computer is going to be completely encrypted, at least all the used disk space on it. And if somebody steals my computer, well, if they can't log in, they can't get to my data. So now that BitLocker is encrypting, I want to talk about something important, and that's a TPM chip. I'm going to click down here, the TPM administration link. So a TPM chip is a trusted platform module chip, and it's a little security chip that's built onto your motherboard, and it's tamper-proof, so people can't use wires and hardware to sneak in there and pull the data off of it. The TPM chip is required if you want BitLocker to start up automatically without requiring you to put in a USB flash drive. So BitLocker, in order to decrypt all the data on your drive when your computer starts, it needs to use a certificate. The certificate has the decryption key in it. Of course, this certificate is really, really important, right? Because anybody with that certificate would be able to encrypt your data. So you need to keep that certificate safe because your data is only as safe as that certificate. So BitLocker by default will store your certificate in this TPM chip because the TPM chip is really safe, and you can use this tool to manage it, though you don't ever really need to manage your TPM chip. BitLocker will do it for you automatically. Some computers, older computers, don't have a TPM chip. So let's take a look at a scenario with a computer that doesn't have a TPM chip. So in this scenario, you have a big and bulky desktop computer with a ton of confidential files on it. You work at a company that has a security guard manning the front desk 24/7, so you're not worried about somebody breaking in and physically stealing the desktop. But it does occur to you that there's a scenario where somebody could steal all of your data quite easily. Like a lot of workstations, your computer has hard drives that are designed to be easy to remove. In fact, they're mirrored. Mirrored copies data between two different hard drives, and if one of them fails, it can automatically switch over to the other one. It's common to make these hot replaceable, meaning you can pull them out while the computer's running. That also makes theft ridiculously easy. Say the cleaning person who has access to your facilities decides he wants to take your data home with him. He could just pull out that hard drive, go home and connect it to his own computer and read every file on your computer, unless of course you encrypt it. And that's what we're going to do. But this older computer does not have a trusted platform module chip. Well, good news, BitLocker does support computers without a TPM. It takes an extra tweak and a little more work, but it can be done. So let's go through that scenario now so we can protect that confidential data on the desktop computer. So here we are on my Windows 8 desktop without a TPM. So I'll repeat the process I did for my laptop computer by searching the settings for BitLocker and then launching the BitLocker Drive Encryption tool. Now I'm going to warn you this isn't going to work, but I'll click Turn on BitLocker here, and you can see I get an error message. This device can't use a TPM. But there's another way. You can go in and manually change a policy setting to allow BitLocker without a compatible TPM. Now, why do they do this? Why do they provide this capability, but only if you jump through an additional hoop? Well, if you use BitLocker without a TPM, BitLocker becomes a bit more of a nuisance because you need to store the certificate somewhere, and you can't use the TPM, which would be terribly convenient. So you need to store it on basically a USB flash drive, which is inconvenient. And if you lose that flash drive, you lose access to all your data, unless you type in the 48-byte recovery key. So that's why Microsoft doesn't think that BitLocker without a TPM is kind of an ideal scenario, and they turn it off for you. So to enable BitLocker without a TPM, we need to change a group policy setting. And it's easy to do this by editing the group policy object in a domain environment. You can also do it on your local computer by running gpedit.msc. This opens the group policy editor. And you can find the relevant policy under Computer Configuration, Administrative Templates, Windows Components, BitLocker Drive Encryption. And then within BitLocker Drive Encryption, you see 3 folders here that relate to fixed data drives, which would be like your D or your E drive, removable data drives, which are USB flash drives, and the most important, operating system drives. And if you only have one drive in your computer, as most computers do, that's the only drive you're going to have. The operating system drive also allows you to protect your Windows system files. So you don't need a TPM chip ever to encrypt your data drives or your removable data drives. You do need a TPM chip by default to encrypt your operating system drive, unless you go in and you change this policy, which is require additional authentication at startup. By enabling this policy and then selecting the Allow BitLocker without a compatible TPM checkbox, we can allow the computer to use BitLocker on the system drive without having a TPM present. So you see a bunch of different options here for BitLocker and the different options available to you. You can start up either with a PIN, a startup key, which is a USB flash drive, or a combination of a startup key and a PIN. So as you can see, besides allowing it, which allows the user to choose what they want, you can also require it. So if you have policies that require it for your organization, you could pick it from there. But for us, we just want to do it for our one desktop computer. So I just need to choose allow, and then I can make my own choices later. So with that policy changed, I can close the local group policy editor and try to turn on BitLocker again. This time it's working, great. So now it's going to ask me how to unlock my drive at startup. And as I was describing, you get a choice between putting in a USB flash drive or entering in a password. It needs some sort of security. So I think the easier option is to enter a password, and it's because I lose all my flash drives and stuff. I can't be trusted with that, so I can mostly remember a password, and hopefully you can too. So I'll put in a strong password. Of course, you don't want it to be easily guessable, and click Next. Just as before, I have to back up my recovery key somewhere, and I like to use my Microsoft account for that. And the same option, I'm only going to choose to encrypt the used disk space to save time. And you can see here it's a little more paranoid. It wants to run the BitLocker system check, but I'll bypass that and start encrypting immediately. Great, so we can see that the encryption is in progress. So let's let that encryption complete, and then we can restart and watch the startup experience when BitLocker is protected by a password. So now encryption is complete, my data is safe. Let's just reboot so that we can see the experience. All right, so now BitLocker is prompting me to enter in a password. At this point, the data on my drive is completely encrypted, and whether I was a hacker trying to boot from Linux or a legitimate user who forgot their password, I wouldn't be able to access anything. So all I need to do is to type in my password here and then press enter. And you can see Windows is starting, no problem at all. Now I'm going to try that one more time, and we'll pretend that we forgot our password, because after all, that's a realistic scenario too. I forget my passwords all the time, so we'll restart once more. And this time you can see down here, press escape for BitLocker recovery. This is what you do if you forgot your password, and it's going to ask for this 48-bit recovery key. Now, you saw that I saved it in my Windows Live account. I could log into that from a different computer and get it, and then type in the whole thing here, and it would immediately start up. And then once I was logged into Windows, I could change the password on the BitLocker drive. So you can see that without a TPM, the data on my drive will be protected, whether somebody tries to access it in my own computer or whether they move that drive to a different computer and try to boot from it. They don't have my password and they don't have my recovery key. They don't have my data. That's why BitLocker is great. Now let's take a look at BitLocker to go. Whereas regular BitLocker encrypts fixed drives in your computer, like your system drive or an internal hard drive, BitLocker to go encrypts USB flash drives, the type that you use to transfer files between, say, a work computer and a home computer. BitLocker to go is really, really important because these USB flash drives are often used to transport confidential files, and they're also really easily lost. It's easy to be fishing through your pocket to get your keys out, and then they fall out in the parking lot, and then somebody else finds it, and they're like, hey, free drive, right? Well, they get home, and of course they want to see what was on there. What if it's like your financial reports or your personnel data? Don't think about yourself doing this, but think about all the idiots you work with. Those guys, they're clumsy oafs, right? And they don't have a lot of sense. Well, BitLocker to go can protect you from this kind of nightmare scenario. So let's imagine that we want to take home some confidential files and we don't want to bother with a VPN. We want to copy it over on a USB flash drive. But we're not a dummy and we're going to encrypt that drive just in case something terrible happens. So here we are on our Windows 8 computer, and I've connected the drive. I'll drop out to the desktop and open up File Explorer. And here we can see the drive with my confidential files on it. Now, you can turn on BitLocker for removable flash drives using the control panel tool that we used for the other scenarios, but I think it's easier just to go into Explorer, right-click the drive, and then click Turn on BitLocker. This opens up the exact same wizard that you would see. So you can see it's initializing the drive now. It warns you not to take it out, obviously. And now you get to choose how you want to unlock the drive. Most of us are just going to use a password to unlock it. You can see an option here to store the certificate on a smart card instead. But I think most of us just want to type a password and get access to our data. So I'll type a password and then click Next. As when you protect a system drive, you need to save your recovery key somewhere. And you have the same option here to encrypt just used disk space or the entire drive. If it's a brand new drive that hasn't previously had confidential data on it, you can save yourself a lot of time by just encrypting the used disk space. And then click Start Encrypting. Now, if you have a lot of data on the drive, this could take half an hour. If you only have a couple of files, it could be done in seconds. Now I'm ready to remove the drive and connect it to my other computer. So here we are on our home PC, and we'll connect the USB flash drive now. And you can see a notification appears and tells you that the drive is BitLocker protected. So I'll just click that notification and it prompts me to enter the password. And that's all it takes. The drive is unlocked, all the files are decrypted. I'll jump out to the desktop and open File Explorer. And here we can see our super secret files. Well, they don't actually have any text in them, but we can get to the files and edit them, no problem at all. Now, you'll get that same experience using Windows Vista or Windows 7. And in fact, there's even a plugin for decrypting the drives on Windows XP computers. So there's a really broad range of compatibility. Now I'd like to show you the various BitLocker policies that you can configure in a group policy object. This allows you to configure the settings either for one computer using local policies or for all the computers in your domain using Active Directory group policies. From the start screen, I'll just type gpedit.msc. It's just a shortcut, a quick way to open up the group policy object editor. Now, the settings for BitLocker are located under Computer Configuration, Administrative Templates, Windows Components, and then BitLocker Drive Encryption. And you can see 3 subfolders here relating to your fixed data drives, your E drive, your operating system boot drives, and removable data drives. They each have separate policies relating to them. In the root here, we see some really critical policy settings, though. This is probably the most important in an Active Directory environment. Store BitLocker recovery information in Active Directory domain services. What this will do is once you enable the policy, it'll create a backup of the recovery key and optionally the decryption key in the Active Directory. You can see you can choose between storing just the recovery passwords or the key as well. Might as well store them both. In an Active Directory environment, this is important because a lot of your users are going to be using BitLocker, and a lot of them are going to be forgetting their keys or their recovery password. So they need to be able to call IT, and IT needs to be able to recover their data without having to restore it from a backup. When you enable this policy, it stores it in the Active Directory, so anybody with access to the domain controllers and proper privileges can get that recovery key and help the user out. You can edit this policy, choose how users can recover BitLocker protected drives to prevent users from using recovery passwords. You would only do this if you felt like the recovery password was a security risk, as if somebody might guess a 48-bit hexadecimal password. You also have the option here of 256-bit recovery key. That's only 8 bytes, but it's still quite a few different possible combinations. And these recovery keys are typically stored on a USB flash drive. They're not something you would type in directly. You'll see 2 different options here for configuring the encryption method and cipher strength. Cipher strength is how long the encryption keys are, and a longer encryption key is always more secure. The other policy relates to Windows 7 and earlier versions of Windows. Now, you can see by default it uses AES 128-bit security. AES is just a particular algorithm that they use. You also have the option of upgrading to AES 256-bit security. Now you might think 256 bits must be twice as secure as 128 bits, right? Not quite, because 129 bits would actually be twice as secure as 128 bits. So 256 bits is exponentially more secure than 128-bit security. It's also a lot more work for your computer to do as it's encrypting and decrypting the data, and that means that it's going to slow down your data access a little bit. It's going to make your drives a little slower if you jump up to the 256-bit encryption. So for that reason, 128-bit is standard, and I would only use the 256-bit encryption if regulatory or policy requirements force you to. So some government agencies need to use AES 256-bit security because for whatever reason they decided 128 bits, maybe that's crackable in 1,000 years. They thought we need to protect our secrets for longer than that, so you better use 256. Now there are some other policies here that I don't think most organizations are ever going to need to use. For example, this prevent memory overwrite on restart. Well, while your computer's running, it's constantly decrypting all the data on the drive. And so rather than getting the decryption key from the TPM every time it needs to access a bit of data, it keeps a copy of the decryption key in RAM. Now that seems dangerous. It's just got that decryption key there, but That's the only way it can work. Now, if you were some sort of super hacker and you could wire into the computer's memory and extract something from the RAM, you'd be able to get that decryption key, and then you'd be able to decrypt the contents of the drive. Well, guess what? That is feasible, and people can do that. It's not easy. I can't do it. But people with specialized equipment can occasionally extract data from the RAM of a computer. Now, by default, Windows helps to protect from that sort of far-out attack by overwriting the BitLocker data in memory when you go through a normal shutdown process. This extends the shutdown time very slightly, but you could enable this policy to slightly speed up your shutdown time and not bother overwriting where the decryption key is in memory. So again, convenience versus security, and it seems like a pretty far-out security attack, but there you have it. Here under the removable data drives options, I want to show you a couple of really important policies. And this one you can use to require people to encrypt their removable flash drives and force drive encryption type on removable data drives. If you enable this, you can allow the user to choose to encrypt their data if they want to, which is the default option. How many users do you think are going to bother if you just allow them to pick it, right? Or you can require either full encryption or used space only encryption. If you want to be really sure, go ahead and do full encryption. This will require all users to encrypt their removable data drives. And some of them are going to be annoyed by this, but you know what? If it saves one secret from getting out, it could be worthwhile. Now, I'll give you a warning here. Full encryption can take 30 minutes for a typical drive. Use space only encryption typically only takes a few seconds. So if you're going to force it on your organization, you probably should go for use space only encryption. Again, some secrets could be stored on the unaccessed parts of the flash drive, but you have to weigh the security versus convenience as with everything else. Here's another related option. You can see this applies for earlier versions of Windows as well, whereas the last one applied only to Windows 8. Deny write access to removable drives not protected by BitLocker. If you enable this policy, you can choose to prevent users from saving data on flash drives that aren't BitLocker protected. So if you decide you want to force people to BitLocker protect their flash drives, you would also want to enable that policy. And finally, this policy just allows you to disable the use of BitLocker on flash drives if you want. If you disable this policy, users cannot use BitLocker. I don't know why you'd want to prevent them from doing that, but there you have it. Now, earlier we took a look at a couple of the options for your operating system drives so that we could allow computers that didn't have TPM chips to use BitLocker. There are a few more options we should look at here. This one is new to Windows 8 and it's really cool. Allow network unlock at startup. When you reboot a computer and you require a PIN or a USB flash drive for it to start up and decrypt the BitLocker protected drive, well, that's a really safe way to keep your computer. But a lot of administrators need to restart computers when the user isn't there. Imagine if you're applying updates throughout an organization. Well, these updates always require the computer to restart, right? At least most of the time. So when your users come in the next day, their computers have been restarted. They have to type a password and then the restart process starts. And that's usually pretty quick, but sometimes with updates, after you reboot, it needs to apply another update. Sometimes it needs to restart again, and this can get annoying. That's kind of the client scenario. If you have BitLocker applied on a server, it absolutely needs to be able to restart unattended because servers are usually stored in data farms where they don't have physical access or even have a physical keyboard connected. What network unlock does is it allows the computer to restart if it's connected to the Active Directory network. So you can have your password protected BitLocker on your desktop at work and restart it, and as long as it's at work, you won't have to type a password. If somebody comes in and steals that desktop and it's no longer connected to the internal network, they plug it back in their own home and try to start it up, it's going to prompt them for a password because it's not going to be able to find the network server to unlock it. So network unlock provides the convenience of automatically restarting with the security of requiring a password whenever the computer is taken away from its home network. Requires a lot of server configuration, so you won't have to know how to configure it, but I did want you to be aware of the concept because it's a new feature in Windows 8 and it's pretty cool. Another feature that's new in Windows 8 is the ability for standard users to change their password or PIN. And they can do that using the standard BitLocker control panel tool, unless you decide to disable it. So by enabling this policy, you disallow them from changing their PIN or password. And by doing that, you require IT people with administrative access to change their passwords for them. I think it's a great feature to let them change their PIN or password. Previous versions of Windows required them to call IT and open a help desk ticket, and that means they just never did it. And you know the risks of not changing your password. Somebody can get it and you won't know any better. This next policy is important too, especially in the new Windows 8 environment where a lot of people are using tablet computers. Tablet computers don't have a keyboard attached much of the time, and therefore the user doesn't have the option of typing a PIN or a password in the pre-boot environment. So you need to be careful about allowing this. But if you know that people are using Slate computers and they have a keyboard attached, like if they're docked all the time, then you can go ahead and enable this policy to allow them to specify a startup key or PIN. This option to allow enhanced PINs works well on most modern computers. You'll find that on some older computers, they won't allow more complex PINs in the pre-boot environment. So the pre-boot environment only comes into play when you're using BitLocker on a computer with a TPM chip. And you can configure this policy to require PINs longer than 4 characters in length. They go up to 20 characters, but 4 characters is the default. Now, if you want to require BitLocker, you can enable this policy and force drive encryption type on operating system drives. And by default, it will be allow the user to choose, but you can force full or used disk space only encryption. So as before, your most secure option is full encryption. And if you look at the fixed data drive policies, they're mostly a subset of the policies that you've already seen. You can configure them for smart cards or prevent people from writing to them if they're not already protected by BitLocker. So now I'd like to talk about remote wipe. Now, before we think about Windows 8, let's just think about your smartphone, because this is the most common remote wipe scenario. You probably have lots of personal data on there, pictures and contacts, and all your passwords are stored for Facebook and such. And if you lost it, you wouldn't really want somebody going through all that data. So your cell phone provider usually provides a remote wipe capability, and you can call them up and say, hey, I lost my phone, and they'll tap their computer a little bit, and the next time the phone contacts the internet, it will send a message to it to wipe itself, and it'll just be wiped clean. In fact, it'll probably be locked, so whoever receives it can't even use it, but your data is safe. Now, enterprises, when they manage these smartphones and mobile devices, they know they have confidential data on them, so they set up these complex systems that allow the enterprise to wipe it remotely. Windows 8 kind of supports a feature like this. It's listed on the official feature list for Windows 8, and I think the people making this exam saw that it was there and decided to include it, but there's nothing to configure, so there's nothing they can really test you on about this. Windows 8 has only the most minimal remote wipe capabilities. If you use a Microsoft Exchange email server in your enterprise, and you use the built-in mail, contacts, and calendar apps in Windows 8, if you don't use, say, a more sophisticated app, then the Exchange administrator can go into the Exchange server and initiate a remote wipe of just the client app data. So what that'll do is the next time the mail and contact apps go and contact the Exchange server, the Exchange server will say, you know what, you have been compromised, just wipe yourself. And the mail, contacts, and calendar apps will remove all their saved data and then remove the account itself. That means that whoever's stolen the computer can't go check the email, and that's a good start. But it's not really remote wipe. All the documents and everything else are still left on the computer. And again, I don't know why they put these on the exam objectives. There's nothing for you to configure, but that's what remote wipe is, and that's the only way Windows 8 supports it. Well, let's wrap this up with a multi-level scenario. Windows Location Platform. So Windows Location Platform is this very cool, pretty new feature in Windows 8 that integrates with the GPS capabilities that are built into many new mobile computers, especially tablet computers. And these GPS chips, they communicate with the Global Positioning System, which are a series of satellites up in the sky. And by talking to them and doing some math, they can figure out your precise location on Earth. That's super useful if you're running the Maps app or using it for navigation. And it's a little scary if maybe you don't want people to know where you are. Now, everybody has privacy concerns and nobody wants a chip and wants the government watching them. But here's your scenario. You're an IT guy and you're helping evaluate a potential company for a buyout. You work for a big public enterprise company and you're thinking about buying a little small startup. So as the IT guy, they have you going into the office to check out their code and see if their systems are up and how hard it's going to be to integrate into your own systems. And if you give them a thumbs up, they might just buy that little company. Now, that's big news. If that news were to get out to the public, it could drastically impact your company's stock prices. It could also impact the smaller company pretty severely. You could have other people wanting to buy the company. And in fact, if the information that you were going over to that smaller company on a regular basis were to leak to the public and somebody could piece together that it was a potential buyout, stuff could happen that would derail the buyout. So when you're in mergers and acquisitions like that, it's really important to keep your communications and your travel secret. Now, Windows Location Platform starts to seem a little scary, right? If there were some app that inadvertently tracked your location, well, that could be dangerous. Now, Facebook can do this. If you update your status on Facebook, you can click a little thing and it will figure out your location and put it in the status update, and you have to click something. But that's easily done accidentally, and you might just want to be sure that you didn't do that. Other apps might be able to access Windows Location Platform information, such as maybe malware that could be tracking your location. So if you're concerned about security and you don't want people to know where you are, you could turn this off. So let's look at a few different ways to do it. In the first kind of sub-scenario, we're going to think, well, I don't want a particular app to know my location because I don't want to compromise anything. So let's jump over to Windows 8 and we'll turn off the location for the weather app, just because it's the only built-in app that really uses location. So here we are on the start screen, and I'll open up the weather app. And you can see the typical experience here. And you'll see the typical behavior of an app that uses location. It has to ask you permission. This actually isn't coming from the app. This is coming from Windows. The app just says, hey, I want to use this guy's location. It's Windows that intercepts the request and decides, do you want to let this app use it? So an app can't use your location without you confirming it. So I'll click allow just for argument's sake. Now you can see there's terrible weather where I am. Feel sorry for me. Now I want to take away location awareness from this app. So I'll open up the Charms bar and go to Settings. Remember, this is how you configure app-specific settings. And scroll down a bit here to Permissions. And this permissions setting, it's going to look something like this for other apps. And you can see that it has two possible permissions. Location is the key to location awareness. So I'll just turn that off. So now weather won't know where I am, helping to protect my identity. Now, continuing the scenario, I'm feeling a little paranoid. Like, I turned it off for one app that I know uses my location, but what if there are other apps? I'd like to turn it off for any apps that I use on this computer. So I'm going to open up the settings charm here and then go to change PC settings. Now I'm going to select the privacy page, and you can see some important privacy options here. The first one up here, let apps use my location, off. And it's done. Now no apps that I run under my user account can use my location. That's a pretty good level of security. But what if? What if other users use your computer and you also don't want their location to be out? For example, maybe while you're at the corporate environment, you need to log into their Active Directory domain with a different account. Now, you want to make sure that all users on this PC don't have access to the location setting. So we're going to do this same setting in yet a different way. This time I'm going to search the start screen for location and select settings here. And now I'm going to select the location settings control panel tool. This checkbox here, turn on the Windows Location Platform. I'm just going to clear that and then click Apply. And you see something important here. That little shield means it requires administrator privileges. I didn't need administrator privileges before because I was only making changes to my user account. But when you make changes to all user accounts, you have to make system level changes, and that requires administrative privileges. So what I just did was I disabled location awareness for all users on this particular computer. So now I'm pretty safe. I can log in with different accounts and location awareness is turned off. But as an IT guy, I feel like I should recommend to my boss that we turn off location awareness for all the employees who might be working on this particular merger. So let's go into group policy. From the start screen, I'm going to run gpedit.msc. That's just my shortcut for opening up the group policy editor. And now I'm going to find the policy related to location awareness. It's under group policy, computer configuration, administrative templates, Windows components, and then location and sensors. So we have a couple of different options here. You have turn off location, which turns off the Windows components that handle location, so I can enable that. And then you have turn off sensors, and this turns off the actual GPS sensors. So I don't know why you'd want to turn off one and not the other. I guess an app could interface directly to the sensors if it had the proper drivers and bypass location awareness. But if you were to turn off the sensors, certainly location awareness would no longer function. Anyway, we want to be sure that we aren't giving away our location, so we're going to turn off both the location awareness and the sensors themselves. Because this is group policy, if I were editing the domain group policy, it could apply to all the computers in the organization. This is Tony Northrup for TrainSignal, and I hope you found the lesson both educational and enjoyable, and I'll see you next time.